This is Rajat Kumar Shukla from Perpetual Learning. Today we will discuss about the current stress analysis of dielectric bridge converter, which is very hot topic in the dielectric bridge converter operation. As far we have discussed that what is the basic concepts behind the dielectric bridge converter and their modulation techniques, where we have studied the four modulation technique, which is that is a single phase shift modulation, double phase shift modulation, extended phase shift modulation, and triple phase shift modulation. Okay, so let me start. The What is the current stress and what is the meaning of current stress in the dielectric bridge converter, and why it is very important. So before going to that, let me explain you. Today's my topic. Today's my lecture. Which points I have covered. Where what is the current stress? We have to be stated, right? What is the exactly meaning of current stress? And we will after that we will just take a look on the what is the extended phase shift modulation. After that we will try to minimize the current stress. Because what type of current stress is there in the on the devices, and then we will conclude it. So what is the current stress? So current stress in any converter, I'm not talking about here only in dielectric bridge converter. In any converter you can say the current stress in any converter is defined by the what magnitude of current is flowing through the semiconductor devices, right? What is the meaning of what amount of current or magnitude of current and in any converter? So just recall the H bridge. So in H bridge there are devices in this operation where this is the switches. This showing like that, and yeah, this one and this one. This is the output. This is the middle point, right? And this is the DC voltage, right? So in these switches, what current is flowing, that is very important point. Okay, so the current flowing through these switches, that will define as a current stress. But the important point is that current will be instantaneous. So what type of current? I'm talking about the what type of parameter, right? It would be RMS value, it would be peak value, it would be average value. So what type of parameter we have to take of that instantaneous current through this switch? Okay, so this is the one simulated current. I have just simulated it. Maybe it is not visible because of uh, a small font. So I'm just writing here. That is 12 ampere. So this is flowing. This instantaneous current is flowing from minus 12 to 12 waveform in this fashion. Okay. So here I should take the current stress is this point, or I should take the current stress this average value, or I should take the RMS region. Let's say RMS value is lying here in this portion. This red sign. So in this simulated diagram here, the simulated waveform is look like that, and this is the waveform at the extended phase shift modulation technique. I will tell you what is the extended phase shift modulation technique. But before going to that, I want to just explain the what is the current stress here. So here the waveform is look like that. In the blue color fashion, you can see in the monitor here. So which point I have to take for the current stress? This is the one of the question. So usually current stress is defined from the RMS value of the device. Okay. So why it is so important? So if you just look the data sheet, what device you are using here. Let's say I have used the MOSFET here. In place of this device, in place of in place of one switch. So I have used the MOSFET. That MOSFET is gallium nitride type. So here you can see just the data sheet. This is a small portion of the data sheet where I have taken where it is showing the continuous drain current. As you know that this is the MOSFET symbol. So this is a drain current, this is source current. So what current is flowing here in the drain current? This continuous drain current is showing at the 25 degrees Celsius, it would be 29 ampere. So in the simulated waveform, here the current maximum is going to 12 ampere. So is it okay? The question is, the 29 ampere rating is available, the switch, but here 12 ampere is peak is going. Suppose it is 32 ampere peak is going on. The what is the current peak is flowing through the switch. That value would be till the 32 ampere. But in the data sheet is showing this the continuous current rating is at 29 ampere. So it would be fine or not? This is the question. Because 32 ampere is greater than 29 ampere. So what about the device? Device will damage or not? So obviously not, because this is the peak current. This is in pulsed amount, right? So in the pulsed amount, the pulse drain current rating is at 72 ampere. So what is the meaning of pulse? Pulse, that means it would be, you can say whatever the current is here, this portion, and this is suddenly peak till the 72 ampere. It has a capability of the 72 ampere in very small of time, right? So I'm not saying it should be 72 ampere, otherwise device may get damaged. But just try the peak value. Would be near to continuous drain current rating. Then device will perform very well. But there are another reason, that is the power and volt current characteristic of the current volt characteristic. This is not a static. I'm not talking the static characteristic. This is a power reason, where the reason is showing is like that, something about it. So this value is depends on what amount of current flowing through the device and what amount of the voltage flowing through the device. Okay, so anyway, so what I'm trying to say, I'm just saying keep the peak value is going on the 12 ampere, which is considerably less than the continuous drain current 29 ampere. So current stress is less. But what about if I use any different type of modulation? Because this waveform is simulated from the extended phase shift modulation. But if I use the any different type of modulation technique, where the current stress is current peak is going on till the in this case 12 ampere. So in this case let's say 32 ampere or 42 ampere, let's say. So this peak is going on 42 ampere. Okay, so the device rating is continuous current device rating is 29 ampere, and pulse trend current rating is 72 ampere. So it is also look fine. But if you are talking the current stress, then you have to be encounter the peak value also, instead of not instead of along with the RMS value of the device also. So current stress, remember that it would be defined by the RMS value also, or obviously RMS value only, but peak current is also important point. Okay, so just encounter this thing. So what is the extended phase simulation technique? Let me show you. So what is the extended phase simulation technique? In my previous videos, if you go there I have just simulated the single phase simulation technique, and I have just introduced the different modulation techniques here, right? So what is the extended phase simulation technique? Again, this is the question. So let me draw firstly the uh, dual electrode base converter configuration. So in this configuration, here is input voltage and there is our output voltage. So sorry for my writing. So yeah, and this is the transformer. Okay, so here the voltage, let's say this voltage, I mean what voltage is influencing here, this is VAB, I mean transformer primary terminal voltages, and what voltage is influencing here, I mean the secondary transformer voltage terminal, the influencing by the VCD, sorry, VCD. Okay, so the pulse, I mean the switching pulses arrangement in such a way, I mean in such fashion that VAB should be square wave. It means this switch, I mean let's say switch 1, and this switch, let's say switch 4, will be turned on at a time. Switch 1 and switch 4 will be turned on at a time, and this is the switch 2 and this is the switch 3, then switch 2 and switch 3 will be turned on at a time. Okay, and similarly here, let's say this is a switch 1 dash, so here the pulsing arrangement will be different. So let me show you in the extended phase shift modulation technique have a two mode of operation, two case of operation, where the influencing voltage here, I mean the pressing voltage here, I mean in this fashion, let's say here the in the steady state condition there some amount of voltage is V0, then this magnitude will be V0, and this magnitude will be minus V0, and this is the 0 volt obviously. So in the extended phase shift modulation, the, I mean either primary side or secondary side, step wave type voltage will be impressing it. I mean I will show you how it is possible, how this type of switch arrangement is possible to introduce the 0 voltage signal here. So here I mean yeah, so here two type mode of operation is possible when the 0 volt will be lying in the after this spike, or when the 0 volt will be lying along with, I mean during this spike, right here, I mean in this spike mode. So only this type of two mode of operation is possible. So which type of mode you have to be select, this one, I mean this case 1 or this case 2, which type of modulation you have to be select, this is one of the important question. Okay, so I will give you the answer, but before going to that I want to introduce how possible the 0 voltage reason here. So how, which type of pulses you have to be apply here to introduce the 0 voltage switching sequence here. Okay, because there are minus V0, 0 and V0, so three types of voltage level is there. Okay, so here you will apply, let's say this is the switch 1 dash, this is switch 4 dash, switch, this is switch 2 dash, and this is switch 3 dash. So here you will apply the switch 1 dash. Okay, switch 1 dash for the 50% duty cycle 0.5. Okay, this is the switch 1 dash signal will be there. Okay, and let's say this is the switch 1 dash. Okay, now to introduce this 0 voltage, how it is possible the 0 voltage influencing here. Let's, I have a option is switch 2 dash and switch 3 dash. I mean I can turn on the switch 2 dash and switch 3 dash. I mean 2 dash and 4 dash switches is complementary, are complementary switches of the this switch 1 dash and switch 3 dash, right? So switch, if switch 1 dash is a turn on, then switch 2 dash need to be turned off. That means I have only another option is a switch 3 dash, I have to be turned on. If this switch 1 dash and switch 3 dash will be turned on, then I can get a 0 voltage across this transformer, right? Then I have to be turned on switch 3 dash for a small reason, right? Then if switch 1 dash and switch 3 dash will be turned on, then I will get 0 voltage operation of the voltage. This is the 0 voltage. Sorry, this is a VC. Okay. After that, after 3 days, I have to be turned on which switch? Switch 4 dash, right? Because switch 4 dash is a complementary switch, right? This is a switch 4 dash. Okay, I have to be introduced. Then if switch 1 dash and switch 4 dash will be turned on, then what voltage will be influencing here? I mean let's say if I switch 1 dash and switch 4 dash, I mean this is switch 1 dash and switch 4 dash will be turned on, then the this positive voltage will be influencing here, and this negative voltage will be influencing here. So this let's say this is C and D, right? So VCD will be positive again, then it would be positive till 1 dash will be and 4 dash will be turned on parallelly. Okay, after that after 1 dash 2 dash switch will be turned on. Whenever the switch 2 dash and switch 4 dash will be turned on, that means this is a 2 dash and 4 dash will be turned on, then again it would be when the switch 2 dash, once again switch 2 dash and switch 4 dash will be turned on, then again it would be short circuited, then 0 volt here, right? Then again it would be 0 volt, and then minus V naught will be there, because after turning off the switch 4 dash, switch 3 dash will be again turned on, then switch 2 dash and switch 3 dash will be again introduced. Let me show you again. 2 dash, here as follow my cursor, switch 2 dash and switch 3 dash, here in this portion switch 2 dash and switch 3 dash has turned on. So switch 2 dash and switch 3 dash if turned on, then positive voltage influencing here, and the negative voltage across here it would be here. So C and D, CD becomes negative voltage, right? So minus V naught is will be here. So V naught is there, 0 volt is there, minus V naught is there. So similarly you can get wherever you need the 0 voltage sequence, you can easily apply it here. Okay, so this phenomenon is called the extended phase shift modulation, where the 0 volt voltage sequence will introduce either primary side of the transformer or secondary side of the transformer, but not both side. Okay, if it is both side, then it would call as a double phase shift modulation. So remember it. So there are, so if you just recall my question that which mode I have to select, case 1 or case 2. So this is depends, because we will get it two phase shifting here. One phase shift is the outer phase shift between two bridges. Let's say this we call as a phi, and one phase shift, inner phase shift, wherever you are applying the 0 voltage. So let's say in my case this is the bridge 2, where I am just using the 0 voltage sequence. So the switches signal between switch 1 dash and switch 3 dash, let's say this is phase shifted by D1 or D2, or let's say this is a D1. Okay, so phi or D1 you can say, so D1 or D2. So D1 is outer phase shift and D2 is inner phase shift. So as you can see here, the two types of variable we can get, and we can adjust it. Okay, so as we know in the single phase shift modulation technique, uh, the outer phase shift, because there are only one phase shift variable is available, that is outer phase shift. So outer phase shift will be adjusted in such a fashion that what output voltage you will get and what power you have to be transferred, right, and what voltage you have to get, right. But the inner phase shift is depends only on you. Let's say your target is to reduce the current state, which is a very hot topic in the during phase shift modulation technique. So if you want to just reduce the current stress, then D2 will be adjusted in such a fashion. So this is the in that fashion. So where, however, suppose you are changing the D2 in that fashion, then you can select case 1 or case 2 accordingly, that you want to reduce the current stress, or you want to another objective in that way. So now the question is how you will minimize it. So now the question is how you will minimize the current stress, right? So when you will calculate the RMS current through the device in the extended phase shift modulation technique, it will come into the action in terms of function of T1 and T2. I will not write the fully equation because it will take too much time here in one lecture. So that is the reason I'm just giving an idea that how we can minimize the current stress minimization, right? So Yeah, so D1 is a outer phase shift and D1 is D2 is a inner phase shift, right? So the RMS current rating, RMS current of the device you can easily calculate, or you can calculate the reactive power also, right? So here the showing references is a very good paper on the minimization of the reactive power, but not only this one, but it can also help you to minimize the RMS current rating or current stress on the dual electrolysis converter. Okay, so the RMS current, let's say D1 and D2 is unspecified, then you can easily divide the equation in terms of D1 or D2, and you can optimize it what value of D1, because this value will give you D1 and D2 value, I mean, in an optimum way, where you can just plot, I mean, in this fashion, IRMS current D1 and D2, and you will get a surface plot. So here in the surface plot, so whenever you just change the direction, you can easily see that what is the minimum value of the RMS current, and you can easily find out that what value of D1 and what value of D2 is required to maintain your output voltage, as well as what power you have to be transferred, as well as minimum RMS current. And this RMS current is actually related to the reactive power also. So you can make your objective function accordingly. Okay, so what points we have covered in our today discussion? It was the we have studied the different ways of extended phase shift modulation, which is the case 1 and case 2, and we can say there which modulation, I mean, in this type of arrangement we have to check what RMS current value will be minimized, I mean, in which mode. This is the actually question for you if you follow my videos. And the second point, we have just seen that current stress minimization is required thing, because if you don't minimize the current stress on the devices, then the again one more problem will arise, that how much costly device is required. Because if the current stress, I mean, if the current stress is high, then you need more, I mean, you need high or higher rating of devices, then the cost of your converter will be again increase. So this is very non-desirable thing. So you have to be encounter the current stress of the device, and you have to minimize it, right? Now the another point is, we have seen that different modulation scheme can also be used to minimize the current design. It means uh, I have just show you the EPS system, extended phase shift modulation techniques, right? You can use the double phase shift modulation technique or extended phase shift modulation technique. So in the extended phase shift modulation technique and in the double phase shift modulation technique, there are only two variable of control. In fact, in the extended phase shift modulation technique, I mean, two variable of control, that means D1 and D2. But in the extended phase shift, in the triple phase shift modulation technique, triple phase shift modulation, there are three variable freedom is there. That is D1, D2, and D3. So this depends on you. If you increase the complexity, if you increase the number of freedom variable, then you have to be adjust those things, and switching, I mean, and the converter, not converter, I mean, gate signal will be complicated. It will be little bit complex, but it would be more fine for your customer. So thank you for this session, and if you have any doubt and any comment for me, then you can just uh, write a mail in this in this mail ID, or you can just check our website perpetuallearning dot. I mean, you can just check our website. That is perpetuallearning.in. So thank you.